Good morning. My name is Emmanuel Koto, and I'm here to talk to you about our innovations on the selfie stick, which is what we chose as our innovative project. So while the product is fairly new, uh, it's actually the concept of a selfie stick has been around for a while. Uh, to the right of our poster, you can actually see the first ever recorded selfie with a stick, and it's dated back to 1925. And the first patent was submitted by Hiroshi Ueda and Yujiro Mima. But it wasn't called the selfie stick, it was called the extender stick. It was because when he traveled in Europe, he just felt uncomfortable asking people to take the picture of their family, so he thought it'd be a lot easier just to be able to take the picture yourself. So why did we choose the selfie stick? As soon as we had the selfie stick in our hands, we began to come up with innovations to this product. But first, we needed to acquire analytical information pertaining to its durability, need of force, that it would prevent it from bending, and ease of placement of the cell phone in what we decided to call the cradle. We started to visualize a way to approach what kind of information we're gonna collect and how we're gonna collect it. We wanted to find out the torque, how much force is occurring at your hand. So how much force at your wrist you need to apply so that the stick doesn't rotate about the axis, which the axis is would be located at the palm of your hand. And luckily, Dr. Ridavari provided us with a force scale where we could manually input a force or apply a force, and it would measure how much force was being applied to the part of our product. We had to approach this very carefully so that we would get consistent values that we were plugging into our Excel spreadsheet. The purpose of this selfie stick is to be able to place the photographer into the picture. It's as simple as that. Before that, people used timers, but they weren't always reliable. It just took a while to get, which they weren't used very often, so every time they were used, you had to figure out again how well this timer worked, and so on and so forth. And with the age of cell phones also, it just changed the game. In our analysis section, you can see our data put into a graph form. This is showing us the amount of bending that's happening based on the force being applied at a certain distance. The second graph is our spring force measurements. Not exactly certain why it took this latter form. It might have been application error with the force sensor that we use, the force scale, because it was quite difficult to keep a very steady application of force, so we averaged that. So for our suggested improvements,